examples in which we want to find the greatest common factor. Let's start with a 32x to the 5th, 18x squared. Okay, well, first let's remember what the greatest common factor is. Here, the definition, the largest factor that evenly divides all the terms. This over here. Okay, the largest factor that evenly divides all the terms. Okay, so we have 32 and 18, and we want to think of the biggest number that evenly divides both of those. That means divide without getting a remainder. So let's use some arithmetic and break these down and see if we can find the largest number that evenly divides them. I'm going to use these factor trees. So here's 32 and 18. Factor trees are a really useful way of factoring numbers. 32, okay, well it's even, so I know it's divisible by 2. 2 and 16. 2 times 16 gives us 32. Well, 16 is simply 2 times 8, and we know 8 is 2 times 2 times 2, or you can go 2 times 4, and then 4 is 2 times 2. Okay, so 32 is 2 times 2 times 2 times 2 times 2. 18, on the other hand, there's always a few ways to break these down. I'll just go 9 and 2, and then 9 is 3 times 3. Okay, so let's list these factorizations next to each other to get the GCF. 32 is 2 times 2 times 2 times 2 times 2. And 18 is 2 times 3 times 3. You want to list these in ascending order, so as we go up. And then you circle all the factors in common, but look, folks, there's only one factor in common here. So that the GCF jumps right out. If there were more, our GCF would be the biggest such factor in common, but here the GCF is simply 2. All right, but we're not done yet. We also have to consider the x's. The GCF always gets the exponent, the smallest exponent. So here we have x to the 5th, x squared. It's going to be x squared because that's the smaller exponent. So here the GCF of this first example is 2x squared. There we go. Okay, let's look at part B. So we have 15, 25, 27. We want to find the biggest number that evenly divides all three of these. Well, the only options here for 15 are 5 and 3. Or 15 and 1, but clearly 15 doesn't divide these. So let's see here. So maybe it's 5. Well, 5 evenly divides 25, but 5 does not evenly divide 27. So it can't be 5. Okay, well then it must be 3, right? Well, 3 evenly divides 27, but it doesn't divide 25. So it can't be 3 either. Thus, the only number that evenly divides all three of these numbers, all three of 15, 25, and 27, is 1. So we have a GCF here of 1. Right? In mathematical terms, we would say those numbers are relatively prime. Okay, but that doesn't really matter. Okay, C. Well, remember that the GCF gets the smallest exponent. GCF gets the smallest exponent. Okay, so let's see here. So I put a little 1 up here, because remember, if a variable is just by itself, there's a hidden 1 up there in the exponent. So we have p to the 7th, p to the 8th, p to the 9th, the smallest one, p to the 7th. Okay, so let's see here, the GCF of part C then is p to the 7th, and for the q's we have 1, 2, and 3. Clearly 1 is the smallest one. So p to the 7th, and then q to the 1, which we just write as q. There we go, p to the 7th q. Greatest common factor.